A uniform ladder, its weight given 100 newtons, resting against a smooth wall. So we know for the smooth wall, so you should not consider the friction force, because for smooth wall friction force is 0. And a rough horizontal floor where there is a frictional force you have to consider, making an angle of 30 degrees is given in the diagram with the horizontal. Find the force of friction at the floor using the method of virtual work. So this diagram is provided. So it is given in the problem that it is a smooth wall. So I will write it as a smooth vertical wall, and it is given horizontal surface is a rough surface. This AB is a ladder, you can see in the diagram. At point C, there is a force 100 newtons which is acting vertically downward, and angle of the ladder with the horizontal surface given as 30 degrees. Now, he is asking to calculate the force of friction. So now, let us solve this problem. So first, I will draw the pre-body diagram for this. I will write all the forces acting on a ladder with the floor as well as wall. So this is the given ladder. So at point A, we know the weight of the ladder is acting vertically downward. There is a reaction force in the opposite direction, that is towards upward. There is a reaction at point A, that is RA. Now this point is B. This point is C, it is given. So at point C, there is no friction because it is a smooth vertical wall. So I am not writing any frictional force here. Now we know the tendency of the ladder at point A will be towards the right side. The frictional force will be acting opposite to that. That means it will be acting towards left side. Means this frictional force FA is in this direction. Try to understand. At A, this ladder will try to slip in the right direction, but we know the friction force will be opposite to body motion. The friction force is in the horizontal left direction, which we have to calculate. Now at point B, I am not writing any reaction force and I am not writing any frictional force because it is a smooth wall. So you have to consider those forces as a 0. Now the angle of the ladder given as 30 degrees. Using the method of virtual work, we have to calculate frictional force F. I'll assume there is a displacement X along the frictional force FA. We know ladder is moving right side, but I am assuming ladder displacement towards leftward horizontal direction, because as we know virtual means it is an imaginary quantity. So when this ladder is moving towards in this direction, we can see at point C there will be a displacement in the upward direction. So let this displacement is y. If you want, you can also see with the help of a small diagram. I'll explain that also. So this is the initial position of the ladder. At this, there is a displacement towards upward when it is moving towards left side. Now, this 30 degrees is the angle of the ladder with the horizontal. So we have to write equation by using principle of virtual work. Now in the problem, it is given that this point C is a midpoint. This distance is x by 2, means half of the distance, and this remaining is x by 2. Means total length, let's take it as a x. So up to midpoint it will be half of the displacement, that is x by 2 and x by 2. From this equation for y, so y equal to x by 2 divided by tan 30 degrees, means the amount of displacement y along the upward direction can be written as half of the distance x by 2 divided by tan 30. So from this we will get its value as 0.86 into x. Now let us apply the principle of virtual work. Apply principle of virtual work. We know it is algebraic sum of total work done is equal to 0. Work done means it is force into the displacement along the force direction. So let us write all the forces on the given ladder. Now let's see, we know there is a 100 Newton force. I will write that force here. So work done is, I'll write force FA into its distance is x. There is a force 100 newtons which is acting downward, so downward is minus 100 into its displacement about this force, means along the line of action of this force is y, and the work done by this RA is equal to 0. That also I'll write RA into 0 displacement at point A because of RA equal to 0. Now this I'll write as FA multiplied by x minus 100 multiplied by, so instead of y, so I'll substitute this 0.86x plus RA multiplied by 0 is equal to 0. So from this equation I'll get the frictional force FA, because when this x goes to the right side it will become 0, means from this we can write FA minus 100 into 0.86 into x equal to 0. When this x goes to the right side will be 0. This I will write as FA equal to 100 multiplied by 0.86. So this is equal to 86, and the units, see 100 given in terms of newtons, so the units are 86 newtons. Answer we are getting. So there is a ladder, he is asking to calculate the frictional force FA. So I have drawn a free body diagram, and I am writing y equal to x by 2 tan 30 degrees from the diagram. In this you can see, if this angle is 30 degrees, we know this is also 30 degrees. Along this there is a vertical upward displacement y. So this we can write as tan 30 equal to opposite distance, that is y, by, we know this length is x by 2. So from that I am writing this equation. So you can also see in the diagram. I will draw this triangle separately. This is forward displacement y, this length is x by 2 and it is 30 degrees. Tan 30 equal to opposite y by adjacent x by 2. So from that I have written this equation, and by using virtual work principle I am writing work done for each and every force, and in place of this y I will substitute y equal to 0.86x into RA multiplied by 0, because there is no any displacement at point A. So simplifying this equation, I am getting the frictional force FA as 86 newtons. So this is the required answer. He is asking force of friction force. So with this problem completed.